Alright, so we're going to look at graphing inequalities in 2 dimensions. So we've already looked at graphing inequalities in 1 dimension on the number line. Now we're going to look at it in 2 dimensions on the XY grid. And so one method we can do is draw your line as you normally would, as if it was an equal sign. The only thing you need to be aware of is if you have a greater than or a less than, but not an or equal to, the line should be dashed. If it says less than or equal to or greater than or equal to, you draw the line solid. Then we're going to pick a point off to one side. This is going to be a test point. We don't want to pick a point on the line itself. All that would tell us is whether it should be dashed or solid, and we should be able to figure that out from the inequality symbol itself. Once we have that test point, we're going to plug that back into the original expression. You should always go back to the original one because you might have changed something when you were trying to graph it, and maybe you did it incorrectly. So you'll always go back to the original one just to verify that it works in the original expression. And then if that test point gives you a valid statement, it's a true statement, then you will shade the side that you got the test point from. Otherwise, you will shade the other side. So a line's going to divide the XY plane into 2 pieces. One side's going to work, one side's not. So we're looking for all the points that would satisfy an expression. And if one point satisfies it in an area, it means everybody in that area should satisfy it. So let's look at some examples. Let's say we wanted to graph the solution set for this equation, this inequality. 4x plus 3y is greater than 12. So I could solve it and get y by itself and put it in the slope-intercept form. But the way it's written, it might be easier to do the intercepts. So I'm going to find the x-intercept. And just a reminder that to find the x-intercept, you make y 0, and you figure out what x goes with that. So 3 times 0 is 0, so that's just 4x equals 12. Divide both sides of your equation by your coefficient of 4, and you get x equals 3. So x is 3 when y is 0 is your x-intercept. To find the y-intercept, same idea, except this time you make the x value 0, so 4 times 0 plus 3y equals 12. And notice I'm saying equals because I'm looking for as if this was an equation to help me draw this line. So 3y equals 12, divide both sides by your coefficient of 3, and y equals 4. So when x was 0, y is 4. That's our y-intercept. And so I go to draw this graph, and x-intercept of 3, 0, y-intercept of 0, 4. I would normally draw this as a line, but again, remember, because this says greater than but not equal to, I need to make this a dashed line. Now what I need to do is test one side of my graph and see which area works. So let's say I selected this point. This point is at coordinates -2, 1. So when x is -2, y should be 1. I'm going to substitute that into my original expression for x and y. I'm just going to see if this comes out to be a true statement. So 4 times -2 is -8, 3 times 1 is 3, -8 plus 3 is -5. Is -5 greater than 12? No, that's not a true statement, which means I do not shade the side of the line where I got the -2, 1 from. So I'm not going to shade the what you might say, the lower left-hand side. I'm going to shade the upper right-hand side. So all of that shaded area, every single point in that area should satisfy this inequality. Alright, let's look at this solution set, graphing it. X plus 3 is less than or equal to 0. So first thing I want to do is, normally I'd get y by itself. I don't have any y's, so I'm going to get x by itself, subtract 3. X is less than or equal to -3. Just a reminder what type of line this is. This is a vertical line. So we're going to draw this 3 units to the left, and it's a vertical line. And then we can still do this process. We'll pick a point. Let's say I pick this point here at -4, -2. So I'm going to go to the original expression. I'm going to change all the x's to -4. I'm going to change all the y's to -2. There aren't any y's, but I can still change the x to -4. I'm going to add here, -4 plus 3 is -1. Is -1 less than 0? Yes. If you think about it on the number line, -1 is to the left of 0. That means it's less than. So this is a true statement, so I'm going to shade on the side of the line where I got this point from. So I'm going to shade on the left-hand side. There is another way to do this inequalities, for maybe not for this one, but for most other ones. This alternative method, what we're going to do is we're going to write the equation in the slope-intercept form. And since we're talking about lines, this is probably a natural way to approach one of these, is to put it in that y equals mx plus b format. In the process, if we end up with y is greater than, or y is greater than or equal to, what that's going to tell us is to shade above the line. And if you get y is less than, or y is less than or equal to, you're going to shade below the line. And again, the difference between greater than and greater than or equal to is whether one's dashed or solid, respectively, or less than or equal to dashed or solid. One thing to keep in mind, though, while you're solving for y here, putting in that slope-intercept form, if you multiply or divide both sides of the expression by a negative, the inequality symbol switches. Alright, so let's say I want to graph this solution set. So first thing I'm going to do is I'm going to put in that slope-intercept form. So I'm going to move the 4x to the other side, get rid of the coefficient of 3, so divide everybody by 3, and I get y is less than or equal to negative 4/3 x plus 2. And again, the inequality symbols didn't switch because I divided by a positive. No switching when you divide by positives. So now I'm going to graph this line. Y-intercept of 2, slope is negative 4/3, so down 4 from this dot and to the right 3. That gives me a second dot. Draw my line. And this says less than or equal to, so that is going to stay a solid line. And then it says y is less than or equal to, so that means shade under it. So think about what would be under this line would be to the lower left. So that would be the under area. Let's look at this one. This is a little bit more complicated. First thing we need to do is kind of clean up both the left and right hand sides of my expression. So remember to distribute that 2 through and the 6 through. So 2 times 4 is 8, 2 times negative x, negative 2x plus 4y, 6x plus 6y minus 2. So I want y all by itself probably on the left hand side. So let me get rid of the 8 and the 2x. So I'll subtract 8 and add 2x to both sides. That'll get rid of it there. Combine like terms. Now notice I still have a y term on the right hand side. I need to get rid of that now. So I'm going to subtract 6y from both sides. So I have my y's on one side, everybody else on the other. And now I just need to get rid of that coefficient of negative 2 on my y. So I'm going to divide everybody by negative 2. And notice that's going to flip the inequality symbol around because I divided by a negative. Y is greater than negative 4x plus 5. So I'm going to graph that. Y-intercept of 5, slope of negative 4 over 1, so I'm going to go down 4, 1 to the right. It's going to give me a second dot. I'm going to draw that line. Again, it's y is greater than, so it's got to be dashed. It's not or equal to. And then y is greater than means shade above, so you think that's upper right-hand area would be above that line. Alright, so now this problem is kind of a reverse of all the other problems. You have been given the picture, and they want us to write the equation, or the inequality statement from that. So let's analyze this picture and see what we can figure out here. So one thing I noticed is it's shaded above the line. It's above that line there, so it's got to be a greater than or equal to situation. Another thing I noticed, it's dashed, which means it has to be a less than or greater than. Well, if I combine these two together and see what they have in common, I see they both have a greater than, a strict inequality. So far I know my statement's going to look like this. Y is greater than some slope x plus some y-intercept. And so if I look at my graph now, I see that, oh, there is a y-intercept at 0, 1, which means my b value is 1. So if I substitute that into my statement, I get y is greater than mx plus 1. And now I need to figure out what this slope is. So I need a second point to figure that out. Let's say I choose this point. Well, to go from my y-intercept to that point, I need to go 3 up and 4 to the right. Well, that means my slope is a positive 3/4. So if I substitute that into my expression here for m, I get y is greater than 3/4 x plus 1. and there's my final expression. So, just by analyzing these things, you can a lot of times just figure out what this expression is. I didn't really do a whole lot of work mathematically here. It's just a matter of being able to look at the graph and determining how this inequality should be set up from there.